Hello viewers, you are welcome to Tindanious Science and Math Tutorials. We are still treating, calculus. Today we are going to talk about gradient, normal, and tangent. Alright, so if I have my rectangular coordinate system, this will have my y-axis, I have my x-axis, and I draw, let's say, a curve this way. Let's say I have a curve this way. I have a curve this way. Now, any straight line drawn to touch a curve or a circle at only one point without the line passing through the curve is called a tangent. So if I have a circle this way, if I have a line this way to touch the curve at one side, you get it? Without the line passing through the curve, that's what we call a tangent. So from my graph, I can say that this side, this line, is touching the curve at this point. So this is what? My tangent. Okay, so let me call this gradient 1, okay, and this is my gradient 2. So 90 degrees. Alright, so this is, realize that the y-axis this way is normal to the x. So I'll call this normal. Alright. So you draw the curve this way, passing through the point with coordinates, let's say A, then comma what? B. Alright. So the name of my curve is, let's say, f of x, which is equal to what? My y. This way. So now, the gradient of the graph at the point P is always equal to the gradient of the tangent at P with coordinates A, B. Again, the gradient of the curve at the point P is equal to or is the same as the gradient of the tangent at the point P with coordinates A, B. Now, so from coordinate geometry, when I multiply the gradient of this, so m2 times the m1, it should give me -1. Alright? Okay. So the formula for finding the gradient of the tangent. So let's say gradient of tangent. So gradient of tangent is given by y minus my y1 equals my gradient m times x minus my x what? 1. And the gradient of the normal will also be this, the negative reciprocal of the gradient m. So I have y minus y1 is equal to, the reciprocal of m is 1 over m, but I need the negative, okay, so negative reciprocal of this. Then multiplying x minus x, 1 this way. Viewers, why are we saying the gradient is always the negative reciprocal of this when finding for the gradient of normal? Alright, again, from coordinate geometry, we said m2 times m1 is equal to -1. Is that not so? Let's make any of them the subject. So let me assume that, so let's say I'm calling this m1, okay? So let's make m2 the subject, okay? So I'll have m2, so let's have m1, m2, m1 or m1, m2 is equal to my -1. If I decide both are by m1, here to by m1, I will have m2 is equal to what? -1 over what? Over m1. Viewers, this is the reason why we said what is the negative reciprocal of the other. So clearly, so this one is what? -1 over m2. As simple as that. So let's see how we can appreciate questions under this using the same word concept. So viewers, let's take questions. Okay, let's solve questions. So I have this. Find the x coordinates of the point on the curve y equals s squared minus 1 all over x, at which the gradient of curve is 5. So let's see how we can employ the analogy we had from the explanation. Alright, so solution. So I have y equals x squared minus 1 all over x. So we have y equals s squared minus 1 over x. So you know that we have a plus b plus c all over x. This is the same as a over x plus b over x plus c over x. So the same analogy over here. So this is the same as y equals s squared over x minus 1 over x. So y equals, this gives x minus what? According to the law of indices, a to the power -1 is the same as what? 1 over a, provided a is not equal to what? 0. So what I have, 1 over x. So this is the same as what? The denominator, which is the x to the power -1. So this is the same as x to the power -1. We are going to differentiate this. Viewers, if this is your first time, kindly visit my previous lectures on differentiation of functions using the power rule. Everything is well explained. So y equals, when I differentiate x, I will have what? 1. Then minus, so -1 by negative gives positive. So I have my x here. You subtract 1 from the exponent, so I have -2. So therefore, this is the same as, so I'm differentiating. So this is dy over dx. Okay. So this is dy over dx. So I have dy over dx equals 1 plus, this is the same as 1 over x to the power of 2. Okay, so this is dy over dx. And the question says that find the x coordinate, alright, of the point on the curve given this function, at which gradient of curve is 5. So what is gradient? Gradient is the same as what? Dy over dx. Okay, so if gradient, which is equal to 5, we say dy over dx is equal to 5. So therefore, wherever I see dy over dx, I'll insert what? 5 over there. So therefore, I will have 5, the gradient, which is dy dx, which is equal to 5, is equal to the expression we have over here. We have 1 plus 1 over x what? X squared. So again, we multiply through by x squared, since it's the LCM. So here will be 5x squared equals x squared plus what? 1. So we have 5x squared minus x squared is equal to 1. So we have 4x squared is equal to what? 1. Divide both sides by 4, here by 4. 4 cancels 4. You have x is equal to square root of 1 over 4. So plus or minus square root of 1 over 4. So this is the same as plus or minus square root of 1 over square root of what? 4. Okay. So our final answer becomes x is equal to square root of 1 is 1 over square root of 4 is what? Is 2. So you have plus or minus what? 2. So therefore, x is equal to positive half and what? And negative what? And negative half. So the x coordinate is equal to what? 1 over 2, then what? Negative 1 over 2. Viewers, this is the end of the lesson. We'll solve more questions to appreciate the topic we've done for today. Bye.